In this video, we're going to be doing a curve sketching example on how to graph a function without using a calculator. So we start with the function f of x equals negative x cubed minus 3x squared plus 2. And what we're going to start with is the first derivative. And the first derivative by power rule is going to be negative 3x squared minus 6x. Now, from the first derivative, the first thing we need to find are the critical values, and that's taking the first derivative and setting it equal to 0 and solving for x. So I'm going to factor out a negative 3x, and I'll wind up with x plus 2. So that tells me that my critical values are at x equals 0 and negative 2. From the critical values, we're going to set up a mini number line at negative 2 and 0, which tells me that I have intervals from negative infinity to negative 2, between negative 2 and 0 and infinity. I'm going to pick test values and evaluate them in the first derivative. So f prime of negative 3, f prime of negative 1, and f prime of 1. And I'm going to take these, go to the factored form, and we really don't care what the number is. We care what the sign is. We care if it's positive or negative. So I put a negative 3 in here. That's going to be positive times a negative. So that's going to be negative. So that tells me that on this interval, we are decreasing. Put in negative 1. That's a positive times a positive, which is a positive. And that tells us we're increasing. And then putting in 1, that's going to be a negative times a positive, which is a negative, so we're back to decreasing. So there's my intervals right there for increasing and decreasing. And now, because I know I go from decreasing to increasing, I know that I have a min at negative 2. And to get the y value, I'm simply going to plug negative 2 into this equation. So that's going to wind up giving me negative 8, and then negative 2 squared is 4, so that's going to be minus 12, and then plus 2. Actually, the negative here is going to be positive 8, so I'm going to wind up with 10 minus 12, which is going to be a negative 2. So at negative 2, I have a minimum. And then at 0 here, I'm going to go from increasing to decreasing, which tells me that I have a max. So at 0, comma, and again, to get the y value, I go back to the original. At 0, 2, I have a max. So that takes care of my extrema. And that's all I can get from the first derivative. I got my extrema and my increasing, decreasing intervals and my critical values. Now to continue, I'm going to take the second derivative, which is going to wind up being negative 6x minus 6. And then from this is very similar to what we were doing before, but for concavity we find possible POIs. So possible POIs, points of inflection, by setting the second derivative equal to 0. And so what I could do there is just go negative 6 is equal to 6, divide by negative 6, and therefore x is equal to negative 1. Alright, so I have a possible POI at negative 1, so that tells me I'm going from negative infinity to negative 1, negative 1 to infinity, and I'm going to evaluate these in the second derivatives. So f double prime of negative 2, and I'll do f double prime of 0 into the second derivative. So I put a negative 2 in the second derivative. That's going to be a 12 minus 6. That's positive. So that tells me that we are concave up. And if I put in 0, it tells me I'm negative, and that tells me we are concave down. So there are my concavity intervals. And because I have a change here at negative 1, I actually have a POI at x equals negative 1. And to get the y value, I go back to the top here, and I wind up with negative 1 in there. That's going to be Plus 1 minus 3 plus 2. So plus 1 minus 3 plus 2. And that's going to give me 3 minus 3, so I get 0 for that. So I have a POI for that. Alright, so knowing the points, I'm going to plot the points here. With this being the origin right here, I know that negative 1, 0, I have a POI. And then I know at 0, 2, I have a max. And then I have a min at negative 2, negative 2. So those 3 points that are on the graph, I check for all my intervals. What's happening to the left of negative 2? Well, from the left of negative 2, I am decreasing and I am concave up. So decreasing and concave up tells me I look like that. And then I see what's happening between negative 2 and negative 1. Between negative 2 and negative 1, I am increasing and I'm still concave up. So that means I'm going to be looking like that. And then I see what's happening between negative 1 and 0. Between negative 1 and 0, I'm concave down. And negative 1 and 0, I am increasing. So that means I'm going here. And from 0 to infinity, I'm going to be decreasing and concave down. So let's double check. I'm decreasing to increasing to decreasing. So decreasing to increasing to decreasing, which is good. Got a POI right there where there's a change, and I have concave up and concave down with a min here at negative 2, negative 2, and a max at 0, 2 right here. So there's a quick example of graphing an equation without having to use your calculator.